or if you're in my class, you can go to exam information. Okay, I'm ready to get started.
Your socks.
I'm going to start on the first one.
The reindeer socks.
Could you please mute your microphone? Can you guys please mute your microphones? You're making a lot of noise. Okay, thank you. All right, let's calculate the Taylor series for e to the 3x centered at 3, and that means that we're going to make a table. So f is e to the 3x and the center is 3. So we'll have n, and then we want the nth derivative at x. And then we'll want the nth derivative evaluated at 3. And then we'll want the nth derivative evaluated at 3 over n factorial. So the nth derivative is the function itself, e to the 3x. And when we evaluate that at 3, we'll get e to the 9th. Okay? And this column will give us e to the 9th over 0 factorial, which is just e to the 9th. Okay, first derivative. What's the first derivative here? 3e to the 3x, right? And when we evaluated that at 3, we'll get 3e to the 9th. And here we'll have 3e to the 9th over 1 factorial. Okay, when n is 2, the second derivative is going to be 9e to the 3x. Evaluated at 3, we'll have 9e to the 9. And we'll have 9e to the 9 over 2 factorial. Okay, can you see what the pattern is? This is 3 to the 0, 3 to the 1, 3 to the 2. So the pattern is going to be 3 to the n times e to the 9 over n factorial. Does everybody see that? And then what's our Taylor series going to be? Sum n equals 0 to infinity, e to the 9th times 3 to the n over n factorial. And since our center is 3, we're not going to have an x here, but an x minus 3 to the n. Okay, so that's our series. Any questions on that?
Could we do it the other way, like not using the chart?
Okay, not using the chart. You know that e to the x is sum n equals 0 to infinity x to the n over n factorial, right?
Right.
Okay, if we replace x with 3x, we'll have 3 to the n x to the n over n factorial, right? But how do we take care of the center being 3?
Put that in for x and then plug it into the e to the 3x.
Okay, we'll get 3 to the n x minus 3 to the n over n factorial. But what are we missing?
E to the 9th.
Yeah. Where does that come up?
Plug the center into the thing.
Plugging the center in will give you 0. So don't do it this way. Okay.
Oh, fucking dead.
All right. Does somebody have a question?
But the other girl was like, "Can you do it the other way?"
Can you please can you please mute yourself, because I hear you talking to somebody. All right. So don't do it this way. Do it this way. All right. All right. How about this one? Cartesian point 2 root 12 in polar coordinates. Okay. R is going to be the square root of x squared plus y squared. And that's going to be the square root of 2 squared plus 12, which is root 16, and that's 4. So R has to be 4. That means it's not A, it's not B, it's not E. Okay, it's one of these. Fall 15, and I also sent it out in a message. Okay, fall 15. Okay. All right, now what about theta? Theta is the arctangent of y over x. So that's going to be the arctangent of root 12. over 2. Okay, what's root 12 over 2? That's going to be 2 root 3 over 2. Okay, what angle has a tangent of root 3? If you can't remember at pi over 6, we have the coordinates root 3 over 2, 1/2. And at pi over 3, we have 1/2 root 3 over 2. Now, if tangent is y over x, which one gives us tangent is root 3? Pi over 3, that's correct. All right. Yeah, number 1, you want to make a table. If the center is not 0, make a table, okay? All right. Okay, now I also have to warn you, you want to check this, because what you want to do is plot your point in Cartesian coordinates to make sure you're in the right coordinate, the right quadrant. Yeah, r is the square root of x squared plus y squared, x squared, y squared, and that gives us 4. So do you see where r comes from? Okay, theta is the arctangent of y over x. And square root of 12 over 2 becomes square root of 3. Now, which angle has a tangent of root 3? Pi over 6 or pi over 3? Remember, it's y over x, okay? All right, one more thing. If x is 2 and y is root 12, we're in quadrant 1. So you need to make sure that the angle you find is in the right quadrant. So always plot your point in Cartesian coordinates to check. All right?
When we're in quadrant
Matters when you, yes, it does matter when you do arctangent, because arctangent only gives you a value in quadrant 4 or quadrant 1. If your angle is over here or here, you need to make adjustments for it. Yes, it very much does matter. We got lucky here because we were in quadrant 1. Okay, I hope that answers your question. Yeah, you would either have, yeah, you'd have to add pi if you were down here, or if you were up here, you'd have to add pi to get to quadrant 3. Okay, are we ready for this one? Anybody know the equation for this polar curve? No, r equal 4 is centered at 0. This has a center of 2, 0.
Or cosine theta.
Yeah, this is 4 cosine theta. Okay, the r equals some constant times the cosine of theta. This is going to be a circle on the x-axis. All right, and you do a complete revolution from 0 to pi. Remember that? What about this one? A circle on the y-axis. That's going to be r is some constant times the sine of theta. And you also do a complete revolution from 0 to pi. Okay, what about this one? Okay,
radius.
okay, why not 2 cosine theta? If r is 2 cosine theta, r of 0 is 2. Is the point 2, 0 on the circle? It's not on the circle. This is on the circle. Okay, can't be this because the point 4, 0 is on the circle. This one gives you a point on the circle. You see that? Just evaluate theta at 0 and that gives you this point, which is on the circle. Yeah, this is the diameter. Okay. All right, we've been through this many times, those of you who have been in my lectures. Okay, when theta is equal to 0, let's see what we get. When theta is 0, we have 4. Okay, I'll call that point A. Okay, when theta is pi over 2, what do we have? 0. So we're going all the way around here to B. That's when r is 0. And when theta is pi, we have r equal -4. So Instead of being out here at pi, we have a negative, and that puts us back over here. That's point C. Okay, so you just plug in your numbers, you'll see you make a complete revolution from 0 to pi. That's just the way it works out. Same for circles on the y-axis. But for this one, to make a complete revolution is 0 to 2 pi. And that's because it's centered at the origin. And how do you denote a circle centered at the origin? Does anybody remember ours what? Just a constant, right?
The diameter.
R is a constant. This is the radius is a constant. Okay. All right. Let's do radius of convergence for this series. And to do this, we're going to do the ratio test. Let n go to infinity, and we'll have n plus 1 factorial over n factorial, x to the n plus 1 over x to the n, and then we'll have n plus 1 to the n plus 1 on the bottom and n to the n on the top. Okay, so when we simplify that, I'll do that over here. This over this will just give us n plus 1. This over this gives us x. And this is going to give us n over n plus 1 to the n times 1 over n plus 1. Okay, so these two will cancel. Does anybody remember what this quantity gives us from exam 2?
E?
1 over E.
That's 1 over e. So we'll get that the absolute value of x over e is less than 1. And if we multiply both signs by e, you get that the absolute value of x is less than e. Okay, what do you mean the first part? This part? Okay, this is just the n plus 1th term over the nth term. Okay. All right. This one. Okay, this is from exam 2. N over n plus 1 to the n. We can write this as 1 plus 1 over n to the 1 over n. I'm sorry, to the negative n. And that's going to be e to the negative 1. Okay, when you take the limit. Okay, that's about 10 minutes worth of work. It's from exam 2. I don't think you'll need it. It's not L'Hopital's, no. Okay, if you need to see that, I'll have to show it to you, okay? It's not on the exam. Are you sure you want me to show this to you? I'm going to write that as n plus 1 over n to the negative n. And we can write that as 1 plus 1 over n to the negative n. Okay. All right, and this will be 1 over e. All right, thanks. It's not on the exam, so don't worry. Okay, how about number 5? We have a parametric curve for x and t, and we want to calculate the slope and the sine of the second derivative at a given point. Okay, so I'm going to need some more space for that. X is t cubed minus t squared plus t. Y is 3e to the t. Okay, so what's dx dt? 3t squared minus 2t plus 1. And dy dt is still 3e to the t. Okay. So dy dx is going to be dy dt over dx dt. And that's going to be 3e to the t over 3t squared minus 2t plus 1. Okay, now we want to calculate this at the point 0, 3. Okay, so what we have to figure out what is t at the point 0, 3. Okay, and when y is equal to 3, t is equal to 0. Okay, because you can just set these equal to, you'll set 3 is equal to 3e to the t, and that means e to the t is 1, and that means that t is 0. Okay, so when we evaluate this at t at 0, we'll get 3 over 0 minus 0 plus 1, which is 3. Okay? Okay, so that's the slope. So our answers can only be D or E. And now we have to see the sign of the second derivative. Which step? Okay, because X and Y both depend only on T. The only thing you can plug in here is T, so you have to figure out what is T to give you X equals 0 and Y equals 3. Do you see that now? T is the only variable in the right-hand sides here. Is that okay? Okay. All right, now, does anybody remember what's d squared y dx squared? There's a formula for that. It's going to be d dt dy dx over dx dt. Okay, so we're going to need to take the derivative of this. What's the derivative with respect to t of 3e to the t over 3t squared minus 2t plus 1? Okay. What do we have to use here? Does anybody remember what it's called?
Quotient rule.
Quotient rule. So we're going to take the derivative of the top, which is 3e to the t, times the bottom, minus the top, times the derivative of the bottom, which is 16 minus 2, all over the bottom squared. And then we're going to divide that by dx dt, which is this again. So we'll have d squared y dx squared is 3e to the t, 3t squared, minus 2t plus 1, minus 3e to the t times 16 minus 2, over 3t squared minus 2t plus 1 cubed. Yeah, all we need to do is figure out the sign. They're only asking us for the sign here. All right. Okay, now we need to evaluate this when t is equal to 0. So we're going to plug in t equals 0. And what are we going to get? 3 times 0 minus 0 plus 1, minus 3 times 0 minus 2 over 1 cubed. What's that going to give us? Okay, because the derivative has a squared on the bottom, but we're dividing by dx dt. This is, and dx dt is this again. That's how the bottom got cubed. Do you see that? All right. So we'll have 3 plus 6 over 1, which is 9. Okay, that means we're concave up, and the second derivative is greater than 0. All right. Now, look what I did. I did the derivative of this whole thing, and then I divided by dx dt. So this step 1 is here, and step 2 is divide by dx dt, and that's where the, okay, because our input is t. Okay, the input is t here, right? The only variable on the right-hand side is t. So we have to plug in the value of t that gives you x equals 0 and y equals 3. Does it make sense? X is a function of t and y is a function of t. So if you're given x and y, you have to figure out what t is. And we figured out that t is 0. So that's what we plug in, 0. Okay? All right. Okay, who's ready for number 6? Okay, the first thing we have to do is figure out how are we going to represent the log of x squared plus 2x plus 2. Now on your formula sheet, okay, here's the formula sheet you're going to get for your exam. All right. And if you're in my class, I put it on the lecture notes page. Okay, this is the series we have for the log of 1 plus x. Okay, so I am going to write that down. We're going to use that and see if we can rephrase our question. Log of 1 plus x.
You can substitute x for x plus 1 squared.
That's right. We're going to complete the square. We have that the log of 1 plus x is sum n equals 0 to infinity, negative 1 to the n, x to the n plus 1 over n plus 1. Okay, but we have x squared plus 2x plus 2 instead of 1 plus x. So we're going to have to complete the square here. So do you remember how to complete the square? Yes. Yes, he's giving you the sheet. It's inside the exam. How do we complete the square here? We take half of this, which is 1. And then when you square that, you're adding 1, so you subtract 1. Okay? That's from the first exam. Okay, so how do we use this to represent this? We're going to replace x with x plus 1 squared. Does everybody see that?
What about the extra plus 1? What do you do with that?
Right, we have a 2 here originally, and that becomes 1 plus 1, so we have the correct amount too.
Yeah, but when you put it into the other, when you substitute it, what do you do with it? Do you just leave it?
Okay, what are you going to get if you FOIL this out? X squared plus
No, when you put it into a natural log of 1 plus x, because you said we're just gonna square it, right?
we just squared this part. Yeah, I haven't done that yet. Okay, do you see?
Okay.
Excuse me,
Yeah, I get that part.
X plus 1 squared plus 1. Okay, now we're going to substitute x with x plus 1 squared. All right, so the log of 1 plus x plus 1 squared is going to be sum n equals 0 to infinity, negative 1 to the n. And we're going to replace x to the n plus 1 with x plus 1. And we square that, so we'll have 2n plus 2 over n plus 1. Okay. Okay, now we've got a problem here. Does anybody see what it is? Do you see all these answers? What do they start with?
1.
N equal 1. We can't do that because we're not trying to reproduce the log of 1 plus x. We're trying to reproduce the log of 1 plus this quantity x plus 1 squared. You won't get their answer if you just plug in x squared. All right, now Dr. Manley writes this series differently. So I don't want to confuse you because it's not going to be on the test. We don't have to do that, and that's not how you work out this problem. That is how you work out some problems, but not this one in particular. So what we're going to have to do to match one of these is shift up. Okay, and when you shift up from the bottom, that means everybody to the right is going to go down 1. And so to put this in terms of the answers, we're gonna have to start this series at 1. So when we go up 1, that means everybody to the right is gonna go down 1. All right.
Is this a possible like shifting we might have to do on the exam?
No, you're not going to have to do this. The only reason we have to do it now is because Dr. Manley doesn't use the standard formula.
Oh, okay, thank you.
Why did we shift that? Because these answers all start at n equal 1. All right. Just so that we can get something that looks like one of the answers. What happened to the 1 plus? Okay, do you see that this is the formula for log of 1 plus x? We didn't change it. We still have 1 plus something. What changed was the something. If we're shifting down, oh, I'm sorry. Yeah, it's 2. This becomes 2 times n minus 1 plus 2, which is 2. Two n minus 2 plus 2. That just becomes 2n. That's correct. 2n. Thank you. All right, now that was just to write log. Now we want to integrate it. So when we integrate this, we're going to get sum n equal 1 to infinity, negative 1 to the n minus 1. We'll get x plus 1 to the 2n plus 1 over n times 2n plus 1. And we pick up a constant integration. Yeah, because when you replace n with n minus 1, you get 2 times n minus 1 plus 2, and that becomes 2n. Sorry, it was just 2n, okay? All right. And now when you integrate that,
I'm sorry.
Yeah.
I'm a little confused still. In the ln 1 plus x plus 1 squared, where's the 1 plus outside of the parentheses? Like, what do we do with that?
Look at the original formula for log of 1 plus x. This is the formula, right? From your formula sheet?
Yeah.
Okay, so we're not messing with the 1 plus. We're just messing with the x. We're replacing x with x plus 1 squared. Does that answer your question?
Okay.
Okay.
I guess, yeah. I just, so it doesn't do anything.
It's not that it doesn't do anything. This is how you represent it. And we're only modifying the x part to make that x plus 1 squared.
Okay.
And our manipulations reflect that, okay? Okay, now all we have to do is figure out what c is. We're given that f of negative 1 equals 3. So if we plug in negative 1, we'll get 3 equals 0 plus c, and that means that our constant has to be 3. Okay, so which one is it? It's not A and it's not B because they don't have the right constants. It's not C either. It's D or E. Which one's correct?
D.
No, D. Yeah.
D. Do you see that? Is everybody okay with that? All right, who's ready for the next one?
Can you explain really fast how you got the 3 in the front? How you took it out?
Okay, we were given that f of negative 1 is equal to 3, correct?
Yes.
All right, and when we integrate, we pick up a constant, correct?
Yeah.
Now, we're told that f of negative 1 is equal to 3. What's going to happen to this series when you plug in negative 1 for x?
You're going to get 0?
Right, this whole thing is going to give you 0. So you have that 3 is equal to 0 plus c.
Oh,
That means that c has to be 3.
thank you.
Okay?
Yes.
All right, who's ready for number 7? Anybody ready for number 7? Okay. Okay, now we have the log of 1 minus x And that's not on your table, so I'll just give it to you, okay? You're not gonna have to worry about shifting, okay? I don't want you to worry about it because it's not gonna be your exam. It's not gonna be on your exam. But the integral, okay, when you integrate, sum doesn't change, this doesn't change. The only thing is you're using the power rule. And x plus 1 goes to up 1 unit, and then, you know, it's like, what is the integral of x cubed? That's going to be x to the 4th over 4 plus a constant, right? That's just the power rule. You're going up 1 unit and dividing by that new power. That's all you're doing. That's just the power rule. Do you see it? Okay. Okay, are we ready for number 7 now? We want the 9th derivative, and I'm going to have to do this on a second sheet of paper. Okay, so I'm going to give you the series for the log of 1 minus x. And that's just going to be the negative sum, n equal 1 to infinity, x to the n over n. You're not going to have to do that as far as I remember, okay? I think he's going to put that on the final, and he hasn't written the final yet, so I don't know what he's going to do for the final. Okay, now we want f9 of 0. And we've got a formula that the nth derivative evaluate at a is going to be n factorial times a times the nth coefficient, okay? Our a is 0. So we have that the 9th derivative evaluated 0 is going to be 9 factorial times a sub 9. Okay, so we have to go up here and see what's the coefficient when x is equal to, when n is equal to 9. We'll have a negative 1 over 9, right? You see it? The coefficient is everything except the x to the n part. So it's going to be negative 1 over 9. 0 is just what you're evaluating it. The exponent is 9. These n's match. If we have a 9 here, we have a 9 here. Okay? Yeah, coefficient means it's not variable. X is a variable. And a coefficient is not a variable. Okay, is that clear? The coefficient does not include the variable part. So it's just going to be negative 1 over n. No, you can't, because what if he asked you to find the 675th derivative? They generally ask you things that you can't possibly do the calculation for using a regular derivative. They want you to understand how these coefficients work, okay? And I believe he will give you this formula. Let's see. Yeah, here's your formula, okay? So you will get this formula. And you will get a question like this. Promise you'll get this question, okay? Yeah, you're gonna get this question. You're also gonna get a Taylor remainder question for sure, all right? Why is it a sub n times n factorial not divided by question? I'm sorry, I don't understand the question. Are you talking about this question that we just worked on?
Yes, ma'am.
This
Where's-
series, this
I'm
series,
sorry.
it's from Chewing, okay? Yes, there is I just said there's a Taylor remainder question on the exam. No, M will be given to you. Okay, and will be given to you, so don't worry about that. On this one, this is not a Taylor, no, you're only going to be getting series that are on your formula sheet. But this is from a different course. No, you don't have to know this series. You only need to know the ones that are on your formula sheet, okay? Is that good? Okay. All right. Anyway, so f to the 9, the ninth derivative is 9 factorial times -1/9. And that's going to give us -8 factorial. All right. Yeah, the formula sheet is included in the exam. All right. Okay, are you ready for the next one? Okay, what's the question about 7?
Your formula f derivative n a equals n factorial times a to the n. I'm just confused about that because on the other formula it said divided by n factorial. So why?
Well, it's the same formula. You're just going to have to multiply. Okay,
Okay.
what's the coefficient? When n is equal to 9, we're going to have negative x to the 9 over 9, right? If you plug in n equal 9, do you see that?
Yeah.
Okay, so what's the coefficient? Just the -1/9 part, right?
Okay.
All right. I got that formula from a different course. Okay, this is
Okay.
given in Chewy's course. All right.
Okay.
You're not going to be responsible for formulas that I didn't derive it. I got it from a formula sheet from another course.
Sure. Okay.
You okay with that?
Yep. Thank you.
You're not going to be asked things that are not on your formula sheet. So don't worry about where this came from.
Okay.
All right. Okay, can we move on to number 8? No, you're not going to do log 1 minus x. Okay, and I apologize, you guys. Dr. Manley does so many things differently, and it's creating a lot of problems. So I'm sorry about that. If it were up to me, we'd be using Chewy's course, but I'm not the boss. Sorry. Or we'd be doing things consistently with Chewy, but he changes the formula sometimes. Anyway. Okay, let's let C sub n x plus 4 to the n be a Taylor series. Okay, and we're given that the radius convergence is 3. Then which of these x's has to be in the interval of convergence? Okay. All right, so we have for number 8, C sub n times x plus 4 to the n has a radius of convergence is equal to 3. Okay, do you know what that means? It means taking the absolute value of x plus 4, this quantity has to be less than 3 for convergence, right? Is everybody okay with that? And where this came from, it was just given. All right, we can turn this into a 3-way inequality. I can write this as -3 is less than x plus 4 is less than 3. Okay? And I can subtract 4 from all 3 pieces of the 3-way inequality to get that -7 is less than x is less than 1. All right, now let's draw this on the number line. All right, so we know that everything inside here will converge. All right, so which of these x's is within that piece of the number line? Can you see which one is going to be inside? Yeah, only one of them works, and that's this one. This one doesn't work, it's way out here. This one is right on the border, but we don't know what happens on the border. Okay, this one, x equal -6 is inside. X equal 4 is way out here. And x equal -1 is right on the border. We don't know what happens. So the only one that we know for sure. No, because you don't know what happens at the endpoints. Don't know what happens at the endpoints. Okay, so you can't say that they work. Yeah, you don't know what it is. Radius convergence means, this means, okay, this is like a definition, okay? Given the radius of convergence equals 3, that means that the absolute value of this quantity must be less than 3. Okay, and you can't determine if it's equal unless you have more information about C sub n, because you have to do another test to check the endpoints. All right. Okay, who's ready for number 9? Okay, number 9, we have to figure out what this series is. And do you guys know the key to these problems? The most important piece of information here is the denominator. Okay, so you're going to look at your formula sheet and you're going to answer the question, which series has a denominator of 2n plus 1 factorial? Nope, yes, no, no, no. So yeah, it has to be sine. So let's go ahead and copy down the formula for sine, because that one has 2n plus 1 factorial. Notice these all have different denominators. All right, so we know that this has to be a sine. Okay, so sine is sum n equals 0 to infinity, -1 to the n, x to the n plus 2n plus 1 over 2n plus 1 factorial. Okay, what did they plug in for x to get this? Does anybody see what x has to be?
Pi over 6.
Yeah, x is pi over 6. Because we have pi to the 2n plus 1 over 6 to the 2n plus 1. All right. Okay, what else is different? Does anybody see anything different? So if we write sine pi over 6, that's going to be sum n equals 0 to infinity, -1 to the n, pi to the 2n plus 1 over 6 to the 2n plus 1 times 2n plus 1 factorial. That's not what we have though. What's the difference?
Multiply by negative
The
and
alternative
by
is multiplied by -1. So we can notice that -1 to the n plus 1 is the same as -1 to the n times -1. So this is not actually the sine of pi over 6. It's actually the negative of sine pi over 6. Because if we multiply both sides by -1, then we'll get -1 to the n plus 1, pi to the 2n plus 1, over 6 to the 2n plus 1 times 2n plus 1 factorial. Okay, now, who knows what the sine of pi over 6 is?
1/2.
Yeah, it's 1/2, so our answer is -1/2. And is that one of our choices? Yep, it's right here.
I got lost. Why I say negative?
You got lost with a negative sign? Okay, this is what we get when we plug in pi over 6. Do you see that? We just replaced x with pi over 6. But that's not what we have. We have -1 to the n plus 1. Now notice you can write -1 to the n plus 1 as -1 to the n times -1, right? So we can write this series as -1 to the n times -1. So that's just going to give us the negative of the sine of pi over 6, okay?
We're doing what? Oh, you do that anyway.
Okay, can you please mute yourself if you're talking to somebody else? Okay, who's ready for number 10? We want the interval of convergence for this series. So let me do that on another piece of paper. I didn't. That's what they gave us in the problem, okay? And I just rewrote the alternator as -1 to the n times -1. The original series has -1 to the n. but the problem has -1 to the n plus 1. No, it's going to be a few fill in the blanks. Okay, is that good? All right. Okay, who's ready for number 10? You know, I think you go either way with a lot of it. You can go either way. If you got factorials, ratio is better. Sometimes if you just have powers, root might be easier, but I'm going to do ratio for this one. So we've got limit as n goes to infinity, n plus 1 squared over n squared, x to the 2 times n plus 1 over x to the 2n, and then log n plus 1 and log n. All right. So this is going to be, we don't need absolute values because everything's positive here except for the x. I'll keep them on the x. Does anybody see where this guy's going as n goes to infinity? These are both polynomials degree 2. The leading coefficient is 1. Yeah, that goes to 1. And this will be x to the 2n plus 2 over x to the 2n. And where is this guy going as n goes to infinity? This is also going to 1. All right. Okay, so this is going to be the limit as n goes to infinity, x squared. And that's got to be less than 1 for convergence, right? So we can rewrite that as -1 is less than x is less than 1. Okay, now we have to check the endpoints. All right, when x is equal to -1, we'll have sum n equal 2 to infinity, n squared times -1 to the 2n over the log of n. All right, is this ever going to be negative? 18, but some have multiple parts. This is always positive. All right, and somebody already knows that this diverges. It diverges by the test for divergence because the numerator is growing faster than the denominator. All right, let's see what happens when x is equal to 1. And this is always 1. And we get the same thing, divergence by TFD. So our interval is -1 to 1 with both ends open, okay? Okay. Ready for number 11? Yeah, when you plug in the endpoint, if it converges, you're going to change your parentheses to a square bracket, okay? Okay, who's ready for 11? The other question didn't ask for the interval. Okay, we're only checking endpoints if we're asked to. If they ask us for the radius, we just find the radius. If they ask us for the interval, we have to check the endpoints. To determine the bounds, you plug into the original series. Absolutely, yes. Okay. Okay, who's ready for number 11? Okay, what do we have for arctangent of x? Does anybody remember? It's on your sheet. Arctangent of x? It's right here. Okay. Okay, we want arctangent x squared. So I'm going to replace x with x squared. So when we replace x with x squares, we'll have 4n plus 2. All right. Now we want to integrate that. When we integrate that, we're going to still have the summation. We're going to still have -1 to the n. We're still having 2n plus 1 in the bottom. But what happens to the x to the 4n plus 2? That's going to shift up 1 unit, 4n plus 3, and then we're going to divide by 4n plus 3. And we also pick up a constant of integration. Now, does anybody see that in one of our answer choices? Yep, that's the one. No, it was pretty straightforward. Okay, no questions on that one? Okay, how about number 12? We want to graph this parametric set of equations. And this one is also important because I want to tell you something that you probably haven't noticed. Okay, one way that might help to pick out which graph is correct. You can look at the equations for x and y. And what do you notice about x? What are the bounds on x? It's always positive, so x is always great. What's the minimum value of x? It's 1, right? So x is always greater than or equal to 1. Does everybody agree with that? That x will always be greater than or equal to 1? Okay, now can you see these graphs and which ones can you throw out? If x is always greater than or equal to 1, which one can you throw out? Yeah, you can throw out B. What else can you throw out? Yeah, you can throw out D, and you can throw out E. The only ones that fit for X are A and C. Now let's see what's happening to Y. Are there any restrictions on Y? Okay, what's the difference here? Here, when X is 1, Y is -3, it looks like. Here, when X is 1, Y is +3. Why not? What about when T is equal to 6? Oh, yeah. T is trapped between -2 and 2. Okay. Since T is trapped between -2 and 2, the smallest possible Y is -5, right? Yeah. This is the one. Okay. So suppose we gave you X of T and Y of T. And suppose this was 1 and this is Y. Suppose Y was suppose Y did something like this. Okay. You would look at these graphs and look at their bounds. X is greater than or equal to 1 and Y is greater than or equal to 0. And that would let you pick the curve for X and Y. All right. So look, study the bounds on these graphs to help you decide which is the correct graph here. I don't know what it's going to look like, but you will get a question like this on the exam, okay? Where they're going to give you X of T and Y of T, but you have to figure out X and Y. You're going to need to know flowers and circles, definitely. Lemmasons and cardioids might be on the final. Okay, I hope that answers your question. Because he just released homework 20 today. He can't put that on exam 3. Okay, cosine and sine flowers. Y is less than 0 here. Y is less than 0 here. Okay. When t is -2, y is -5. Okay. Okay, and can we work these out in order and then we'll talk about the remainder estimate? Is that okay? All right, let's move on. Okay, if we want the interval and radius of convergence for this Maclaurin series, how are we going to do that?
Find the representation in the series and then do ratio
Right,
test.
and we can find this, yeah, we can find this using geometric series. When we have 1 over 1 minus stuff is sum n equals 0 to infinity stuff to the power n. So we want to make it look like that. So we have to do some manipulations here. So I'm going to write x squared over 1 plus 4x as x squared over 1 minus -4x. Okay, and that's going to be x squared times 1 over 1 minus -4x. And I can write that as x squared times sum n equals 0 to infinity, -1 to the n, 4 to the n, x to the n. Okay, now if I want to make this pretty, I have to pull this x squared inside. So what's going to happen to the index? It's going to go up 2. So that'll be n equals 0 to infinity, -1 to the n, 4 to the n, x to the n plus 2. All right, so is everybody okay with this is equal to this series? Okay, because 1 minus stuff gives you positive stuff to the n. If we have a plus, we're going to have to put an alternator in there. Okay? Are you okay with that, B? All I see is your first initial. Okay? Okay, now we have to do ratio test. We could do root test too. Yeah. But we got this x to the n plus 2. Let's not. Because x to the 2, x to the n is equal to x to the 2 plus n. Okay, this is algebra. Is that okay? All right. Okay, now let's do ratio test to find the radius. And we don't need the alternator. That's going to be 4 to the n plus 1 over 4 to the n, x to the n plus 3 over x to the n plus 2. And that's going to give us 4x less than 1. So the radius is going to be 1/4. So cross out this, this, and this. Okay, notice they both have open at the left. Okay, sometimes we multiply. You're going to have to come up with an example. I don't know when we ever multiply. Okay, these are sums for the power. Okay. So we only have to check the right. We're going to check the right end where x equals 1/4. So what happens when we plug in 1/4 here? Sum n equals 0 to infinity, -1 to the n, 4 to the n, 1/4 to the n plus 2. What's that going to give us? Okay, in problem 11, we multiplied it. That's because we had a squared. That's because we squared it. And we multiplied by 2, okay? So squaring it, that's like saying x to the 2n plus 1 times x to the 2n plus 1, right? And that is the same as x to the 4n plus 2, according to what I just showed you, right? It's the same thing. We added. Okay? All right. Okay, let's go back to this. Okay, now I'm going to break that up. So we have 4 to the n, then we'll have 1/4 to the n, and then we'll have 1/4 squared. And these will cancel. And we'll get sum n equals 0 to infinity, -1 to the n times 1/16. Okay, what is this series going to do? It's going to be bouncing back and forth between positive and -1/16, right? So this is going to be diverges by the test for divergence. So we're open at the right end, and our correct answer is R. Okay, everybody okay with that? Okay, who's ready for number 14? Describe the graph of the parametric curve given by the equations below. Okay, so let's see what we have. T, x is the sine of 2t, and y is the cosine of t. What do we get when t is, how did I simplify inside the absolute value? What, oh, here? 4 to the n plus 1 over 4 to the n is 4 to the 1. That's the 4. And x to the n plus 3 over x to the n plus 2 is x. Does that help? This is 4 to the n times 4 over 4 to the n. And this is x to the n plus 2 times x over x to the n plus 2. So these will cancel and these will cancel, and you just get 4x. All right. Okay, so for number 14, when t is equal to 0, the sine of 0 is 0. The cosine 0 is 1. All right. Okay, how about when t is equal to pi over 2? X is the sine of pi, which is 0. Y is the cosine. Oh, it's the sine of 2. Sine of 2 times the sine of t. I'm sorry. 2 times the sine of t. So this would be a 2, not a 0. And the cosine of pi over 2 is 0. So thank you. All right, when t is pi, we'll have 2 times the cosine of pi, which is 0, and this will be -1. So let's draw what we have, okay? X and y. So 1, 2, -2, 1. Okay, so we start when x is 0 and y is 1. So this is where we start. Okay, and when we're going in the positive direction, x will go to 2 and y will go to 0. So we're going in this direction. All right, so can you tell me, what are we drawing? Does this look like a circle? It's not going to be a circle. If you go all the way around, you'll have symmetry and you'll end up with something like this. So this is an ellipse, right? Okay, and which way is this? Are we moving clockwise or counterclockwise? This is the clockwise direction, right? So you're just going to have to put some points in order to see where you're going. Okay, now we're moving on to free response. Are we ready for free response? Okay, we want arc length. Does anybody remember the formula for arc length? This needs to go in your memory palace. We're going from A to B, square roots. dx dt squared plus dy dt squared dt. All right. Okay, so that means we're going to have to find dx dt and square it, and find dy dt and square it. So what's dx dt? Clockwise. Dx dt is 1 minus 2t, right? What's dy dt? 4 root 2 over 3 times 3 over 2 times t to the 1/2, right? And these will cancel, and we can write that. These will also cancel. We'll have 2 root 2 t to the 1/2. Okay, now let's square them. So dx dt squared plus dy dt squared is going to be 1 minus 4t plus 4t squared. And dy dt is going to be 2 roots of 2 squared is 18. And when we sum these, we'll get 1. Negative 4 plus 8 will give us 4t plus 4t squared. Okay, does anybody see that this is a perfect square? Is this 1 plus 2t squared? Yes. Okay, so our arc length, we're going from 3 to 5. And we'll have the square root of 1 plus 2t squared dt. And when we take the square root, we'll have 3 to 5, 1 plus 2t dt. And now we want to evaluate this. And that's going to give us t plus t squared from 3 to 5. So we'll have 5 minus 3 plus 5 squared minus 3 squared. And that's going to be, yeah, I guess that's okay. 2 plus 25 minus 9. It should be 18. Okay. All right, we ready for the next one? All right. Okay, how about this one? We want to evaluate this integral using cosine. We've got cosine x squared, so we'll have cosine x squared sum n equals 0 to infinity, negative 1 to the n, x to the 4n over 2n factorial. And now we want to put an x in front of it. So we can accomplish that by just adding 1 up here, 4n plus 1 over 2n factorial. And now we're ready to integrate it. And when we integrate, the sum doesn't change. The alternator doesn't change. The 2n factorial on the bottom doesn't change. The only thing that changes is that we're going to use the power rule on x, and we'll have x to the 4n plus 2 over 4n plus 2, and we pick up a constant of integration. All right. Now, what's the constant? What is x cosine x squared when x is equal to 0? Now there's an x in front and x is 0, so that's going to be 0, right? And that tells us that the constant is equal to 0. Okay, so now we're going to use this to make a 10th order polynomial. So t sub 10, we'll see what this has to be. Okay, when n is equal to 0, we'll have negative 1 to evaluate the constant, I plugged in x equals 0. All right. Okay, we want the 10th order polynomial, so we're going to take this out until we get x to the power 10. So when n is equal to 0, we'll have -1 to the 0 over 0 factorial. When n is equal to 1, we'll have -1 to the 1 over 2 factorial, and then we'll have x to the power 6 over 6 factorial. And then when n is equal to 2, we'll have -1 squared over 4 factorial, x to the 10 over 10 factorial. All right, when we clean this up, we'll have 1.
Is 4n plus 2 supposed to be a factorial?
No, we got that from the power rule when we integrated.
So why is it 6 factorial and 10 factorial?
Oh, I think I made a boo-boo here. Thank you. Okay, x to the 6, and that's going to be 6 times 2 is 12. And this is going to be 24 times 10, which is 240. All right. So that's a 10th order polynomial to approximate. So how will we estimate this definite integral below? We'll just plug in x equal 1. And that's going to be 1 minus 1 over 12 plus 1 over 240. And you can just leave it like that for full credit. Wait, why is x equals 0 one more time? Why did I use x equals 0 to evaluate the constant? Is that the question? Okay, because we have an indefinite integral, I can evaluate that constant if I plug in x equals 0, because that integral represents x times the cosine of x squared, right? I'm going to use the fact that I know that x times the cosine of x squared is 0. Do you agree? Because 0 times anything is 0. All right. I didn't plug in anything here, okay? Not yet. Oh, why did we plug in 1? Because we're estimating this integral. We found that this integral gives us this sum, and we can evaluate the integral. This is the integral result evaluated at the upper limit. And then we would have minus, if we plug in 0, we get nothing from here, okay? We get nothing. It means take it up to the power of 10 on x, okay? These two numbers will match. Whatever they tell you down here, this is the power of x you use. Because that's when you plug in n equals 0. Wait, oh, you're right. This should be 1 squared. I'm sorry, x squared. I'm so sorry. That was my mistake. Thank you for catching that. No, because 0, wait. When n is 0, you'll get x squared. Oh, you're right. I made another boo-boo, didn't I? This is over 2. You're right. I'm so sorry. 1/2. And I even had it when I worked it out before. I had 1/2. I'm sorry. Thank you. Thank you. Thank you. I'm so sorry. Thanks for catching that. This is over 2. Okay, everybody got my boo-boo? Everybody fixed my boo-boos. Thank you. And this would be evaluated at 0. Okay. So this is at the left end, and this is I'm sorry, this is the right end, and this is the left end. Okay, got it? This is the upper limit, this is the lower limit. Okay, and you can just leave it like that. Okay, we've got, I think, one more, and this is your favorite. I know this is your favorite. No, we got, yeah, one more. Taylor series, and we're going to make a table for this. Okay, so our center is 2, so we're going to evaluate it at 2. And then after we evaluate it at 2, we'll divide by n factorial. Okay, so when n is equal to 0, we have 3x plus 3 to the 1/2. Okay, what do we get when we plug in 2 for x? 6 plus 3 is 9, and the square root of 9 is 3. All right. You know, I just don't have that many, so I'm going to try to round up something that looks like what you'll see on the exam, okay? And he's going to give you m. Okay, when n is equal to 1, the first derivative will be 1/2 times 3x plus 3 to the negative 1/2 times the derivative of what's inside, which is 3. And that's going to give us 3 over 2 times 3, which is 1/2. So we can write that as 1 over 2 times 1 factorial. Okay, the second derivative is going to be 1/2 times negative 1/2 times 3x plus 3 to the negative 3/2 times the derivative of what's inside, which is 3. But we already had a 3 there too. Okay, so this is going to give us a negative 3 squared over 2 squared times 3 cubed. And we can write that as negative 1 over 2 squared times 3 squared. Okay, let's see if we can find a pattern. Okay, we don't alternate sign until the second derivative, so that suggests to me to write the first 2 terms separately. So we're going to write f of x is 3 plus 1/2 times x minus 2. And then we'll have a sum starting from n equal 2 to infinity. Two factorial. Okay, I need to do one more to see the pattern. Okay, we're going to have 1/2 times negative 1/2 times negative 3/2, 3x plus 3 to the negative 5/2, and then we'll have 3 cubed. And the fourth derivative is going to be 1/2, negative 1/2, negative 3/2, negative 5/2, 3x plus 3 to the negative 7/2, 3 to the 4th. All right, so this is going to be one of those monsters where the sign is alternating. And we're going to have negative when n is even. So we're going to have a negative 1 to the n plus 1 to make it negative 1 when it's even. Now, what's happening on the top? This is where those running products come in. We're going to have 1 times 3 times 5 dot, dot, dot. Now, how do we get to a 5 when n is equal to 4? That's going to be 2n minus 3. Okay. All right. And then we're going to have a 3 to the n. And then we're going to have x minus 2 to the n. Now, what's going on with the denominator? We're going to have 2 to the n. And then what's happening with this guy? This is going to be 3. Okay, if we start with n equal 4, we get to 7. That's 2n minus 1. All right. So if you remember those series you had to work on for the second exam where they had those running products and nobody liked them and we used ratio test on them, do you remember those problems that kind of look like this? Okay, now you know where they come from. We weren't just trying to torture you. Those were Taylor series for radicals. Okay, so they actually do show up in real life. Okay, he's not going to give you anything this complicated. No, you won't have anything this difficult. Okay, between tomorrow, when I see you tomorrow, I will give you a much better heads up. Okay, the reason we write these two separately is because the terms don't start alternating sign until the second one is the first one that has a negative. Do you see these two have the same sign? They don't follow pattern. Yeah, I'm having another review at 3 p.m. Okay, these two don't follow the pattern for the alternating sign. This is where the sign starts to alternate. What happened to the 1/2 and the 7/2? Okay, the 7/2. Okay, when you plug in 2, you're going to get a 3 here, right? 3x plus 3 square root. Square root of 9 is 3. So this is actually, this gives us in the denominator 3 to the power 7. And we can represent that as 3 to the power 2n minus 1. Okay, because when n is 4, 2n minus 1 is 7. When n is 3, 2n minus 1, all right, when n is 2, 2n minus 1 is 3. Okay, so if we did it for here, we would have something over 3 to the 5. So we represent these numbers by 2n minus 1, okay? Okay, so I'm going to give you Taylor remainder tomorrow, and we also have the spring 19. Oh, you want the remainder problem. Okay, I'm going to put it on pause while I find a remainder problem for you. Okay, so this is log 1 plus x. We're going to write out the series, but we're going to put negative 1 to the n plus 1, x to the n. Okay, so we have log of 1 minus x. So we're going to have negative 1 to the n, negative 1 to the n plus 1, x to the n plus 1 over n plus 1. Yeah, but that's not going to be, I'm showing you one that's consistent with his exam, okay? Let me use the one that's consistent with his exam. Okay, so that's going to be negative 1 to the 2n plus 1. And what's this going to simplify to? Just negative 1, right? It turns out to be the same thing. Okay. Negative n equals 0 to infinity, x to the n plus 1 over n plus 1. Okay, we want the second degree Taylor polynomial, so that's going to be negative. When n is equal to 0, we'll have x to the 1 over 1. And when n is equal to 1, we'll have x squared over 2. And then x cubed over 3 plus dot, dot, dot. Okay, so the second degree Taylor polynomial of 1 minus 1/2 is going to be the negative of 1/2 plus 1/2 squared over 2. That's to the second degree, right? Okay, our Taylor remainder estimate tells us that the remainder for n, where n is degree 2, is going to be less than m times the absolute value of x minus a to the n plus 1 over n plus 1 factorial. Okay, and he gave us to use m equals 16. So that's going to be 16. And here's our formula. So n is equal to 2. So let's let x minus a be 1/2. 2 plus 1 over 2 plus 1 factorial. So that's going to be 16 times 1/2 to the third power over 3 factorial. So that's going to be 16 over 8 times 6. Anybody know what 16 over 48 is? 1/3. All right. No, the remainder, you don't have a polynomial, okay? M will be given on your exam. No, for the first part, okay, this is the second order polynomial, and I think he wanted you to plug in 1/2 for x. Okay, remember, you're going to take the largest value in this interval. Second order means go up to x squared. Okay, second order, x squared. So third order, x cubed, and so forth, all right? Yeah, we wanted both the approximation and the error. All right, but yeah, that's correct. Okay. The 2n plus 1. Okay, this is the same question you've been having. You got the same base, but different exponents multiplied together, you add them. N plus 1 is 2n plus 1. Do you see that? Just add the exponents. Do you see? N plus 1. Okay. All right, so -1 to, okay, -1 to the 2n times -1 to the 1. No matter what you plug in for n, this is always going to be positive. Okay, let me show you that. -1 to the 2n. Okay. Let's make a table for n. When n is equal to 0, -1 to the 0 is 1, right? Do you agree with that? All right, when n is equal to 1, -1 squared, that's equal to 1, right? When n is equal to 2, -1 to the 4th is equal to 1, right? Do you see this is always going to be even? So you're always going to get a positive 1 out of it. You see that? Okay. And that's what you have to do. If you can't do these things quickly, you're going to have to write something out to convince yourself that the answer is correct. Okay? So if I'm going too fast for you, that's okay. You ask me for details, but don't be afraid to go through this same process yourself. If you were told it was less than a given number, like 1/1000. Okay, like if what was less than a given number? Oh, the error? If the error is less than 1000? Okay, then what you would have to do is you would have to keep writing terms until they were less than, and this would not be a good one to do it because the denominators are so little. But most series will start getting huge denominators and you won't have to take it out that far. But yeah, if you were given, you have to come up with something that the error is less than 1/1000. Yeah, just keep taking terms. And yeah, second order means go up to x squared. Third order or degree, they're the same thing, okay? It's not n equal to, it's the power on x that matters, okay? The order, the degree matches the power on x. It doesn't necessarily match the index, it's the power on x, okay? Okay, any other questions? No more questions? Why is x minus a 1/2? Remember, you want this to be the maximum value in your interval. So I just plugged in x itself, which is 1/2. Okay, you want this to be the biggest value in your interval. Because we want the biggest possible. we want it big here. So want x minus a to yield largest number in the interval. All right, so that's really the question. Oh, if he says let x minus a be something, yeah, you would use that something. Instead, he's telling you what m is. Yeah, let me get out the textbook. Okay, hold on. That's really a good question too that you're asking. All right. Okay, see these, for example. Are these? Okay, I mean. Okay, here, for example, you have x as a function of t and y as a function of t, and then you have to pick the parametric curve that matches it. So for this one, you'll notice that x is bounded by 1 and 2. So this cannot be the graph because x goes from negative, it goes from a little bit less than -2 to, so it can't be this one because x is between +1 and +2. And this one, is x between +1 and +2? No. Is this one x between +1 and +2? Yes. This could be a possibility. Okay, let's figure it out. Okay, what's y doing? Y is between -1 and +1, right? Right? Yes. So is y between -1 and +1 here? Yes. So this is the answer to the first one. Okay, that would be one example. All right, I think you can figure it out from there. All right, I'm going to call it quits because I've got another review that I have to do. And Mama Bear is getting tired. So I will see you guys at 3 o'clock tomorrow, okay? All right, thank you for coming. All right, thank you for coming. I really do.